So, if you know the joint probability mass function, so suppose this the joint probability mass function of x y is known. So, that means p x y of x I y j, it is given for all I is equal to 1 to j, it is given the CDF, joint cumulative distribution function of x y is given by is given by f of x y x comma y. So, this is equal to probability that x less than equal to x, y less than equal to y. So, how we can find that? So, it is actually summation of all I and all j p x y of x I y j such that x y will be less than equal to small x and y j will be less than equal to small y. X and small y are fixed, all I j satisfying this relationship I j, then we will take the sum, then we will get the cumulative distribution function from the joint probability mass function. It is very similar to the invariant cases we discussed. So, these are the some of the properties of the joint probability mass function. Let us discuss one numerical example. Before that, we want to compute these things also, that is why we need to clear this concept. How we can find? Suppose the joint probability mass function of x y, that is p x y of x I and y j is known. Now, we want to find the marginal probability mass function. That means, whenever your joint probability mass functions are given, jointly the probability, it is known to us. How we can find the marginal? Means the subset of this vector, it is called a random vector. So, subset of or component vector means here only two variables x and y. So, we want to find the probability mass function of x and probability mass function of y. So, how we can find probability mass function of x? So, probability the marginal probability mass function P.M.F of x is given by, so this is nothing but f x of some x I. This is nothing but probability x is equal to x I. How we will find that? So, this can be represented as, because this is a event, x equal to x I is a event, that can be represented by intersection of s, because x is equal to x I is a subset of s. So, it is a subset of s. So, x intersection x I, intersections for all sample space, this is nothing but just x equal to x I, this event. So, now s can be represented as x equal to x I, it can be represented as union of all j y is equal to y j, because if you consider y is a random variable and it is taking some values y1, y2, the y3 like this, and that if you take the union of all possible values y can take, this will be nothing but s. So, s can be represented as y is equal to y j. Now, if you use a distributive properties, this is nothing but union of all j x equal to x I intersection y is equal to y j. So, then we use the axiom 3. So, this is union of all j x equal to x I intersection y equal to y j. So, then union, because these are all disjoint, y1, y2, y3 are different. So, that is why they are disjoint. So, this is nothing but summation of j probability that x equal to x I intersection y is equal to y j. So, this is nothing but summation of j probability that x is equal to x I comma y is equal to y j. So, this thing is nothing but summation of j, this thing actually this is joint probability mass function of x I y j. So, basically what we found? So, if you want to find the probability mass function of the marginal probability mass function of xi using the joint probability mass function, you fix particular values of xi and then you sum, fixing xi, you take the sum of the other values yj. So, it is summation of j pxy of xi yj. Similarly, we can find the marginal probability mass function of y is given by P of y yj. This can be find summation of, if you take the sum over all the other variable xi yj. So, then you will get the marginal probability mass function. It is similarly like what we did here, you have to make it x, then yj fixed. Now, if you take sum of the other values of xi, the other component xi. So, then you will get the marginal probability mass function of yj. So, this is the probability of y is equal to yj we will find. So, that is the concept here, it is written, you can see here that how we can find the marginal probability mass function. So, suppose that for a fixed values x and xi, the random variable y can take the only the possible values yj 1 to n, then probability that x equal to xi, this is the marginal probability mass function, can be found taking sum of all the other values yj. Similarly, if you take the summation taken is over all the possible pairs xi yj, fixing xi is fixed. Now, similarly, if you want to find y equal to yj, then you fix the yj and then sum of the other values of xi for pxy of xi yj, where the summation is taken over all possible pair xi yj with yj fixed. The probability mass function px of xi and py of yj are referred to as the marginal probability mass function that we mentioned here x and y respectively. Now, with respect to marginal probability mass function also, how we can represent that two random variables are independent. So, pxy of xi yj, this is nothing but probability that x is equal to xi and y is equal to yj. So, it is actually comma means it is this event xi intersection y is equal to yj. So, if we can find that this is equal to x is equal to xi, because a intersection b it is independent, whenever we say that this is equal to probability of a intersection b is equal to probability of a into probability of b. So, if this condition satisfy, it may not be that always it will be satisfied. If this condition satisfy for all ij, for all I equal to 1 2 and j is equal to, for all ij if this is satisfied, then x and y are independent random variable. So, if this satisfied for all xi. So, it may be true that for particular values of xi and yj that is true, but it is then we cannot say that xi is a independent random variable, xi y are independent random variables. For independence we require this condition should be satisfied by for any I and j, then only we can say that x and y are independent random variables. So, this is the some joint probability mass function we discussed, and they are marginals how we can find using the joint probability mass function, and how we can define the independence. So, here actually x and y are independent random variable, then this will be true for all xi and yj belongs to the range of xy, we can say, or we can say that for all I is equal to 1 to j is equal to 1 to. So, it has to be represent, it should be represented here that for all I and j. Now, we discuss one numerical example here. Consider this. Consider an experiment of drawing randomly 3 balls from an urine containing 2 red, 3 white and 4 blue balls. Let us consider an experiment of drawing randomly 3 balls from an urine. So, basically there is a urine. So, suppose urine, and then 3 balls from an urine containing 2 red balls. So, there are 2 red balls and 3 white ball 3 white ball and 4 blue balls and 4 blue balls, and it is randomly mixed and they are equally likely. 3 balls are drawn randomly. So, basically see that there are total 4 plus 3 7 plus 2 9 balls are there. So, 3 balls may contain 2 red ball, 1 hot ball, it may contain 3 blue balls also, but 3 red ball cannot contain because there are only 2 red balls, 3 white ball may be coming. So, any possibilities it may come 3 balls. Now, question is that or this is, let x y be a random variable where x and y denote respectively the number of red and number of white ball chosen. So, x is the random variable defined by number of, x is the random variable, number of red balls chosen, red balls, and y is the random variable is the number of white balls chosen. So, y is the random variable that the number of white balls chosen. So, respectively red ball and white ball chosen. Find the range of x and y. First question is that A, find the range of x and y. Let us find the range of x. Now, whenever you will draw a 3 balls, what would be the possible number of red balls? So, red balls may be, it may be 0 because 3 blue balls, then no red balls, it may be 1, it may be 2 because maximum 2 red balls only there. Now, what will be range of y? Range of y will be there, it may be 0 white ball because if 3 blue balls are there, then there will not be any white balls. There will be 1 white balls can be possible, 3 white balls, so 2 white ball also be possible, and 2 white balls may be possible and 3 white balls may be possible. Now, find the range of x y. I just found the range of x and y. Let us found range of x y. Range of x y means this R of x y. So, what the possible random variable as a bivariate random variable, what will be the range of this bivariate random variable? So, it will be in a this will be a subset of R2 actually. So, we just R1, it is a subset of R1, but so what are the possible, like red ball may be 0, white ball may be 0, it can be possibility, red ball may be 0, white ball may be 1, it may be another possible, red ball 0, white ball 2, and red ball 0, white ball 3, these are possibilities. Now, red ball 1, white ball 0 possible, red ball 1, white ball 1, it is also possible, red ball 1, white ball 2, it can be possible, but red ball 1, white ball 3 cannot be possible because maximum 3 balls we have drawn. So, that is not possible. So, now red ball 2, white ball 0 it is possible, red ball 2, white ball 1 it is also possible, total 3. There are no more possibilities, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, 9 elements are there in this set in this range of the x y. So, this is the range of x y. Find the joint probability mass function of x and y. So, joint probability mass function if you want to find, so that means you have to find Px y of ij where I and j belongs to this. So, I comma j belongs to r x y, because these are the possibilities only you have to check. So, this is nothing but probability of x is equal to I comma y is equal to j. So, that we have to find out how we can find. So, for any ij belongs to, for all ij belongs to x y. So, I am not writing x I y j because here x I is equal to I, y j equal to y j. So, that is why for simplicity let us write x equal to x I, x equal to I, y is equal to j. Now we will find the probability one by one. Suppose if you consider this element. So, that means we want to find Px y of 0 comma 0. See, this is nothing but probability that x is equal to 0 comma y is equal to 0. So, x equal to 0, y is equal to 0, if you want to find the probability, that means this is nothing but number of, if you draw the 3 balls, number of red ball is 0 and number of white ball also 0. So, how it can be, what will be the possibilities? Now, how we can find the probability? Now, because it is equally likely, now the total possible way you can draw the ball, total possible 9 balls are there, 3 balls you are choosing randomly 9C3. Now, from red ball you are choosing 2 0, for the red ball we are choosing 2C0, 3 possibilities, and from the white ball also choosing 0, and from the blue ball 4 blue ball we are choosing 3. That is the possibility that red also 0, white also 0. So, now if you can simplify these things, basically 4C3 is nothing but 4, only this is 2C0 0, 3C0 0, 9C3 actually we have computed it is nothing but 84. So, you can check that whether it is correct, 9C3 nothing but 84. So, similarly you can find suppose other values, suppose let us consider 0 1. So, 0 1 is nothing but probability x y 0 1. So, this is nothing but probably that x is equal to 0, y is equal to 1. So, total possibility 9C3 and number of red ball is 0, 2C0, and number of white ball is 1, then 3C1, and then the remaining 4 will select 2. So, 4C2, then that is the possibilities. So, this probability it is coming like because it is I is 0 1 2 0, okay. So, this is what we found 0 1, 18 by 84. So, that you can check that whether it is correct. So, because it is nothing but 3C1 is 3 and 4C2 is 6 into 3 18, 18 by 84. So, this is actually 18 by 84. So, similarly in general we can write P of x y. Now, we can understand that by computing this how we can write generally. So, generally we can write P x y of I j, P x y of I j is nothing but P x y of probability that x equal to I comma y is equal to j. So, then this probability how out of 2 I ball are chosen, red ball, out of 3 j ball chosen, and remaining out of 4 this will be total 3 number of balls minus I plus j. So, this is the combination and this is nothing but 9C3, and this probability this equation work whenever I will be less than equal to 2 greater than equal to 0, j is less than equal to 3 greater than equal to 0. Not only that, I plus j should be less than equal to 3 greater than equal to. So, I plus j greater than equal to I plus j can be 0 also, because I 0 j equal to 0 possibility. So, I plus j is, so only these cases this probability is this, otherwise this is 0, for any other cases this is 0. So, now if you represent graphically now as a table only, so this is nothing but I is I j. So, let us because it is less space, so let us write here. So, here actually I, this is j, this is 0 1 2 0 1 2 0 1 2 3. So, 0 0 we found that this is 4 by 84, this is 18 by 84. So, similarly you can get the other values also, here it is written. So, you can see that 0 0 4 by 84, 0 1 18 by 84, 0 2 it is 12 by 84. So, now and 0 3 it is 1 by 84. So, now 1 0 it is 12 by 84, 1 1 it is for 24 by 84, 1 2 it is 6 by 84, and 1 3 not possible because total ball is 3, that is why 1 plus 3 4, that is why it is 0. Now, 2 0 4 by 84, 2 1 it is 3 by 84, 2 2 it is not possible, that is why this probability is as 0. So, that is why the joint probability mass function it is okay, we found it. Now, find the marginal probability mass function of x and y. Now, we will compute the marginal probability mass function. So, marginal probability mass function, how we can find that? So, the marginal probability mass function So, let us write down this value 18 by 84, 12 by 84 and then 1 by 84, 12 by 84, this is 1 by 84, 1 by 84, the next line is 12 by 84, 24 by 84, 6 by 84, 12 by 84, 24 by 84, oh sorry, 24 by 84, then 6 by 84, this is not possible. The next line is you can see that whether these are correct, 4 by 84, 3 by 84, 4 by 84, 3 by 84, this is 0, this is 0. Now, the marginal probability mass function will find the marginal probability mass function of x is, how we will find that? This is Px of xi. So, here I just xi is equal to I. So, this is nothing but probability that x is equal to I. So, for because range of x we know that range of x is nothing but 0, 1, 2, only 0, 1, 2 we have to find what are the probabilities. So, by definition we already found that what is the this is we have to take the sum of all other values of Pxy of join xi I and j, I comma j. For example, if you want to find Px of 0, this is nothing but probability that x is equal to 0, this is sum of all j Pxy of 0 j. So, this is nothing but Px of 0 0 plus Pxy of 0 0 plus Pxy of 0 1 plus Pxy, let us do on the other pages. So, let us next page let us find out. So, we want to find marginal probability mass function. So, the marginal probability mass function of x is given by Px of suppose I. So, this is nothing but probability that x is equal to I. We know that this formula is Pxy of I comma j. So, here for I is belongs to, this is the range 0 1 2. So, suppose if you want to find Px of 0, this is probability x is equal to 0, summation of j can be 0 to 3, possible values of j is 0 to 3, Pxy of 0 comma j fixing I. So, this is nothing but Pxy of 0 0 plus Pxy of 0 1 plus Pxy of 0 2 plus Pxy of 0 3. So, see that fixing 0 we want to find Pxy 0 0 is this is, Pxy 0 1 is this, Pxy 0 2 is this and Pxy 0 3 is this. So, that means if you take the row sum here we will get Px of 0. Similarly, you can see that if you take the row sum here you will get Px of 1. Similarly, if you take row sum here you will get Px of 2. So, now Px of 0 how what is the value? So, if you sum this 18 plus 12 this is 30, 30 plus 4 34 plus 1 35. So, this value is nothing but 35 by 84, this is the Px 0. Now, Px 1 will be 12 then 36 plus 6 42. So, this will be 42 by 84, this is Px 1 and Px 2 will be 7 by 84. If you add the row sum this is nothing but 7 by 84. Now, if you take the sum of all these value then it should match with 81. So, this is you can see that. So, 84 by 84 this will be is equal to 1. Now, how we can find the marginal probability mass function of this? So, this function this is we got 35 by 84. So, that 35 by 84 and other value also you can similarly you can compute. So, now what will be the marginal probability mass function of y? The marginal probability mass function of y is given by, so P of y j. So, this is nothing but probability of y is equal to j. So, we know that if you take the sum of other values 0 to 2, x can take Pxy of I j for j belongs to 0, 1, 2, 3 for range of y, for j belongs to range of y. So, range of y is nothing but 0, 1, 2, 3. So, 3. Now, suppose if you want to find suppose P of y of 1 suppose, then this is nothing but probability that y is equal to 1, which is summation I is equal to 0 to 2 Pxy of I we are taking I comma j is 1. So, then it is nothing but Pxy of I is 0 1 plus Pxy of 0 2, sorry not 1 is fixed here. So, this is I varying 1 1 plus Pxy of then 2 1 2 1. So, here you can see that Pxy of 0 1, Pxy of 0 is this, and Pxy of 0 sorry Pxy of 0 1, Pxy of 0 1 is this, this is 0 1, this is 0 1, Pxy of 1 1, then next is Pxy of Pxy of 1 1, Pxy of 1 1 is this. So, this, and then next is Pxy of 2 1, 2 1 is this. So, because we are fixing the 1 here, so that is why this is sum of the column 1. So, this is nothing but the Py of 1, this is nothing, this is same as equal to Py of 1. So, similarly, if you fix 0, then it is column sum nothing but this is Py of 0. Hopefully, you have following this. So, this is this row sum is nothing but we are getting the marginal of x, column sum we are getting the marginal of y. So, this is Py of 2, this is Py of 3. So, what are the values? Let us compute that. So, then this is 20 by 84 equal to this. So, this is nothing but this will be 18 plus 24. So, 24, 34, 42, 42 plus 3, 42 plus 3, 45, 45 by 84, and then this is nothing but 18 by 84, 18 by 84, and this is 1 by 84. So, you will take the sum, if it is correct, then this should be is equal to again match to if you take the sum here, it should be 1. So, in this way we can find the marginal probability function or probability mass function of y. Here you can find the marginal probability mass function of x. So, this is the questions, find the marginal probability mass function of x and y, we have found that.